As the original inventor of the Clark oil stop valve, AFL Industries, a division of RGF Environmental Group Incorporated, continues as a market leader with our next-generation oil stop valves, oil water separators, industrial wastewater treatment and reclaim systems. AFL and RGF have over 70 years of combined innovative design and manufacturing experience. AFL Industries produces fiberglass monolithic molded oil water separator tanks using a polyisocyanurate foam core. Polyisocyanurate is known for its use as rigid insulation in the construction industry. Using this method of construction, the tanks can be rated for up to an R24 insulation value. AFL's tank design is capable of withstanding 160 mph winds and a workable 100 PSF live roof load rating. This is the inlet of the VTC 300A2. It's a 300 gallon per minute tank with an integrated onboard oil storage tank. This specific model is designed to be mounted above ground on a level surface. The inlet port can be connected to on-site plumbing, using an expansion joint allowing for thermal expansion of parts, absorption of movement, and vibrations. To the left of the inlet, you will find visual confirmation of current oil capacity. This sight glass serves as a secondary oil capacity indicator for the maintenance crew. This VTC 300A2 is designed to retain 600 gallons of oil in a chamber separated using a partition from the main oil water separation chamber. The sight glass also has two ports in which you can connect to for oil containment samples. The manual drainage port for the oil retention tank can be found here. The primary oil drainage port can be found on top, connected plumb to a pneumatic oil sludge pump. This is the air diaphragm pump discharge line. It can be switched manually by a valve up top to discharge sludge from the bottom of the tank. There are 3 ball valves used for draining the tank's 4 chambers. This is the bird's eye view of our VTC 300A2. At the inlet port of the tank, you can see an FRP constructed inlet baffle used to diffuse the effluent as it is forced into the tank. This baffle is designed to accomplish 2 things. It's forcing the water to come up from lower sections of the separator across through the coalescing media, and it assists in the separation of sediments. The first and second chamber is designed to remove the majority of sediment before the effluent passes through the coalescing chamber baffle. The coalescing chamber can remove oil content down to 5 ppm conservatively if the oil water separator is operating under design conditions. Going back to the inlet chamber for the tank, you will see our 4.5 kilowatt immersion heater, which is installed from the top using a flanged connection for easy cleaning. This pipe plumbed to the ARO pump is used for sludge draw-off. The pipe is plumbed through the bottom of the main chamber beneath the coalescing media. The coalescing media used is a polypropylene material, which is oleolithic and designed as a cross-hatched matrix for significantly higher surface area. This particular oil water separator was designed with a chemical injection tube for pH adjustment. Often, customers request specific customizations to their tank design in order to facilitate their environmental needs. As the effluent passes through the coalescing media, small oil globules are attracted to the oleophilic tubes, attaching to the media to form larger oil globules. These larger globules are able to rise faster, and once they have floated to the surface, they are skimmed off using our adjustable rotary pipe skimmer. The rotary pipe skimmer is designed to be placed 1/4 inch above the maximum operational water level. As the oil is skimmed off, it's transferred into the oil retention tank, which is separated by a seal partition wall. The oil retention tank is plumbed to the ARO pump for discharge. The oil retention tank is also equipped with an explosion-proof wideband oil level sensor. This sensor is the primary indicator of the oil level and is connected to the control panel's audio-visual alarm. The sight glass, which we reviewed earlier, serves as a secondary check to the level switch. After the effluent has passed through the first 2 chambers, removing the oil and sediment, the effluent then passes through the baffle wall, which has an opening designed to draw water from the lower portion. Then traveling up to the 3rd chamber's sheen baffle, which is designed to retain any residual oil sheen. The effluent then passes over a weir wall. This is used to set the differential height of the effluent across the tank. This tank is equipped with 2 discharge points. On a standard unit, it would have a single discharge point placed slightly lower than the inlet port. The tank also has a multi-point level switch connected to the control panel's warning indicators and alarm system. Level switches are used to control pump outflow and alert the user of possible issues. This is the discharge port of the system. It has a lead lag pump system comprised of two 3-phase 480-volt pumps. The pump skid is designed for redundancy and overflow conditions. If one pump were to fail, the user can close these valves here. Once the valves are closed, the user can proceed with maintenance to the pump while the second pump still controls the discharge flow, reducing downtime. The discharge port is equipped with an expansion joint for connection to on-site plumbing. The entire pump system is put on an FRP skid, and the pump stands are constructed from FRP stainless or aluminum, based on a customer's request. This tank boasts a large 4x5 epoxy-coated NEMA 4X electrical control panel. Here you can see the system's lights for the effluent pumps, level sensors, and immersion heaters. Inside the control panel, everything has been neatly configured by our control panel shop, which conforms to UL 508 standards. The alarm system is placed on the top of the control panel with audio and visual signals. For more information on AFL's superior products, call 1-800-842-7771 or visit us at rgf.com/AFL-industries.